I think we're ready. Oh, let me go here. Dev, everybody codes, echoes of Enigmatus, solutions, quest 1. There. Okay. I think we're good. And then here was just a bacon test. Enig 0 tests. All right. Let's start. Now that we have everything set up, echoes of Enigmatus, quest 1. Among the ivory-covered ruins of a castle once home to the famous Sir Enigmatus in Cryptus, a group of knights from the Order of the Golden Duck finds a hidden passage. It leads them to a forgotten room. In the middle of the room, they discover a dusty chest, and inside it, a strange book. It feels mysterious and important, but the pages do not contain only normal writing. They're full of number patterns, shapes, and weird symbols, and some parts make no sense at all. It must be the work of Sir Enigmatus in Cryptus himself. What is inside the book, and why are so many pages completely blank, including the last one? Ooh. Oh, this is the solution. Right. So as we've solved things, we should be able to see things show up on the last page. Will you be the one to break the code? I hope so. I don't know what the difficulty is on these guys. These could be really easy ones just for fun, or they could be really hard ones, or anything in between. So let's just dive in and see how bad it is. Quest 1, EniCode. I really love Monica's woodblock print style of art here. Let's zoom this in because this is very small. And unfortunately, I can't make that part go away, but at least we're zoomed in a little bit. Here we can, there we go. All right, part 1, story section. Oh, they have a separate story section versus the actual puzzle. Okay, so if you want to just skip the story, you can skip the story. But I'm not going to skip the story. While browsing the book, you come across one of the frames marked your answer. So you take a closer look at the nearby notes. So Modulus's work on number remainders, oh boy, has led to some fascinating ways of hiding messages, difficult or even impossible to break without forbidden magic. One method in particular stands out, the PM, power modulus technique. I saw that coming. The good news is we already have code in Advent of Code library to do the power modules. I already wrote it, so I'm not going to write it again. This technique, there's a video link to it. It says, you can just watch the video and then learn about it. I'm not going to watch the video on stream, but maybe after the stream I'll take a look. Allows for incredibly rapid calculations of remainders when numbers are raised to massive powers and divided by any number. The method uses a very clever trick that allows the bypassing of many multiplications and the remainder calculations along the way. What if I devised a function that doesn't allow for such a shortcut? I shall name it Any, after my name, Enigmatus. The Any function takes 3 arguments in this order, n, exp, and mod. The number n is multiplied by itself many times. Primary exp says how many times the number n is multiplied by itself. Number mod is used to take the remainder after each multiplication. All right, that sounds like power mod. Algorithm works as follows. Start with 1 and prepare an empty list to store the remainders. Okay. Multiply the score by n. Take the remainder after dividing by the score by mod. Yep. Add this number to the start of the list of numbers. Okay. Repeat the multiplication, remainder, and appending steps exp times. The final result is effectively a number formed by joining the remainders list as a single number. Okay. For example, NE245 is 1342 because we start with 1, we multiply by n, and mod by 5, we get 2, so now the remainders list is 2. We take 2, multiply by 2, which is n, mod by 5, we get 4, so now our remainders list is 4, 2. And they could be any number of digits, right? Up to however many digits are in the mod minus 1. Right? Okay. And then we just need to convert that list into a number. All right, this seems straightforward. We could just brute force it. We don't have to pull out, these are bigger. Oh, they're only bigger because, okay. Yeah, let's brute force it for the first one. We have some test code. We have some actual input. So let's actually cat greater than input 1. Oh, that's not bad. That's not bad. And then we have test 1 here. I triple clicked it and it just did something over here that I didn't read let me triple click again. Copied. Okay, so it says copied. Oh, now it's waiting for me to exit out. Okay. So let's cut that into test 1. Okay. Parsing this is going to be a little annoying, but okay. So what are we trying to do here with all these numbers? There's a formula for summing 3 calls of any function with specific parameters. AXM, BYM, CZM. Okay. For each set of parameters, a list. Calculate the final result of the formula above. To check the calculation, simply define the highest number obtained this way, and the book will automatically verify the result. Okay. So we just do 3 of them. We sum them up. And then whatever the biggest one is. Oops. I didn't mean to. I double-clicked. And it copied the thing. Okay, if I double click here, yeah, it's okay. It's just going to do it everywhere. All right, very good. What's the highest number obtained from the list of parameters? Okay, so we have the input. We have test code, and we can look at our test code here. And so we should be able to just write this pretty quickly. I imagine parts 2 and 3 are going to make it more complicated. But just to remind myself, I do have in my Advent of Code library, which I've linked to already, my AOC lib, under Math and Magic, right at the top, the very first thing is PowerMod. Okay, so I've already written this code. Like I said, I'm not going to write it again. But it's basically, you're basically multiplying it. You're shifting the exponent down and you're multiplying by the mod. Squaring it and then modding the square. And for every bit that's set in the exponent. So you're doing multiple multiplications based on the bits that are set in the exponent. It's just a faster way to do it because then you're just doing a log of n for the value instead of n, which is a lot faster, especially when n gets really big. Although in these cases, n is not very big, so we're going to just brute force it. Yeah, the exp in this case is the second parameter, and it's going to be x, y, and z. And x, y, and z are all in this first step. X, y, and z are all small. So we're going to brute force it. The first thing we need to do is figure out how to input these things. So we're going to have a struct entry, I guess, which is going to have an a b, c, x, y, z, and m. So yeah, and m. B, C, X, Y, Z, M. Very simple. Impl from stir for entry. What I want to do, oops. Okay. What I want to do is write a little bit of code that'll just strip numbers and return them as a list of numbers so we don't have to do all this massive parsing. If I write that for my AOC lib, I think that'll be useful in general. Because the order doesn't change here, right? So if I just say, okay, take this first line and give me a list of all the numbers in it, then I can assume the first one's going to be A, and the second one's going to be B, and the third one's going to be C, and so on. But meanwhile, until I write that, let's do it here. Let's call this line. And what we'll do is we'll split words, let words equals line split on that, collect into a vec, right? And then we're going to just, for now, I'm just going to do this to make sure everything compiles. Okay, self. That's going to make it harder. Okay, let a, b, c, x, y, z, m equals 3, 4, 5, 6, 7. Okay, a, b, c, x, y, z, m. And it's just going to do that for now. Okay, so that's that. So let's say we can say let a is equal to words of 0 split once on an equal sign, and it's just a equals number. So we can take this second parameter, unwrap, take the second parameter, and then parse that and unwrap it. And we can do that for all of them. Right? B, C, X, Y, Z, M. And then these are word 0, 1, 2, 3, 4, 5, and 6. All right, that gets built. And what we can do now is say let lines is equal to AOC lib read lines of input 1.text. Oh, we should start with test 1. And then we can print out all the entries. Let entries is equal to lines, iter, map, line parse as entry, unwrap, collect into a vec. And then we can just print that out. I have to add debug to this and hit run. There we go. Okay, so hopefully those are the right answers. We got 5 at the beginning to, here. 4, 4, yep, to 11, and then 8, 8 all the way up to 16. Okay, so we got the test code. Let's test the test code. Actually, you know what we could do is we can just leave this as input. And we can write a test mod, test any. And what we can do is generate entry is equal to a colon entry is equal to this first line, which I already have, right? Parse unwrap. I think that'll work. Let's just put these up here for now. All right, so we can use those for our tests. And then we'll just call, so this should be 4, okay, so we're going to just, this is on the whole thing. So this should be this number here, right? So entry calculate, I guess, but I want to have a separate any function that we can test. So this is test line 1. Sure. And then over here, if I test it, if I run it, it's going to fail because we don't have calculate yet. And right now I'll just return 0 for calculate. Oh, not in here. Impl entry, fn calculate, self, usize 0. All right. So now we have left is this and right is 0. So what we want to do is calculate the any value, ENI value. So let's test that. We know that 4, 3, 11 is 954. So let's test various ones. Test 4, 3, 11. Sure. It's 954. So we can say, I guess I could just make it a separate function, 4, 3, 11, like that. And this is n, exp, and mod. Oh, I know, I can't use mod. I can use mmod, I guess. Mod is a reserved keyword in Rust, as you can see there. Okay, so now we're just going to implement this algorithm, I guess. Just do it the brute force way for now, and then we'll see what part 2 brings us. So let's start with initial score. Multiply the score by n. Score times equals n. Very good. Take the remainder after dividing the score by mod. Oh, yep, so we can say let remainder is equal to score mod. Add this number to the start of list of remainders. So we're going to have a list of remainders. Mod list is equal to vec new. Oh, to the start of list of remainders. I guess we could just reverse it when we're done. Sure. So we'll just say list push rem. Repeat the multiplication remainder in appending steps exp times. So while for underscore in 0.exp. Okay, and the final result is effectively a number formed by joining the remainders list as a single number. You know what we'll do instead of this, pushing it directly? We'll say push format bang. Actually, even easier. Let's do it this way. String new. And we'll just say list is equal to format bang rem list. Right? That should give us a result that we can then say list.parse unwrap on. Function any is never used. I think that test passed. Let's ignore this one. Oh, and yeah. So it does say pass. Cargo test. I just want to see it. I want to see it say okay. But Bacon is being helpful and showing me there's warnings that I need to fix before I do that. Okay. So now calculate is just going to be very simple. We're going to call ENI on AXM. What was it? AXM BYM and then CZM? Yeah. Plus any of BYM plus any of CZM. Oh, self. I forgot the self dot. Okay, so those tests now pass. So we should be able to loop through all of the entries. We tested this first one. I don't know if it's worth testing any others. Let's test one more just to be the big one, the one that actually has the actual answer, to make sure we come up with that one. And that's this guy here. So we're going to say, oops. Test line 3. So we'll say let entry colon entry equals this parse unwrap, and then we're expecting the value this. Oops. And the actual one is entry calculate. And that fails because I typoed it. Okay. So I think we're good. I think all we need, all we need to do now is pop up here and then say println part 1 is equal to this. Oh, we should probably put the title here so we can just quest 1 EniCode. Sure. That way we can actually see it in the output, and then we'll just do this. Part 1 is this, and now it's just entries, map, entry calculate, Max, unwrap. I'm just getting the biggest one. Expected semicolon, okay. Iter map. All right, run. We got a number as opposed to the program falling over. And what do we get? Quack, yeah, you're crushing it. That's the right answer. Global time, 3 days, 13 hours, 16 minutes, and 35 seconds, and 456 milliseconds. Thanks for that. Global play 68. Wow. Okay. I guess this is not a very popular one.